Now we discuss the some properties or terminology of the tree. So root. What is a root means? A node without a parent. So nodes means just these are all nodes. A is a one node, B is a one node, C is a one node. So these are all the called as a nodes. The vertices, whatever there that are called as a node. So now a node without parent. So when you take A does not have any parent. So started from A only. Therefore, node without parent is a root. So example is here A. It is started with A only, the tree. Therefore, A is a root. So it has a no any parent. Next is siblings. So now the siblings is nothing but nodes share the same parent. So what is a parent means when you come to the BC, who is a parent? A is a parent. So B for BC, A is a parent. For A, BC are the children. So yeah. Now, what is a sibling means? Nodes that share the same parent. So here BC are the siblings. BC are the siblings. Next, internal node. So next is a internal. A node with at least one child. If a node has at least one child, they are called as a internal nodes. Okay. So for example, A has a three children, one, two, three. Therefore, A is you called as a internal node. Next, A is also root also. Next, when you come to B, at what is that? At least one child. So B has a child, two childs. Therefore, B is also internal node. C is also internal node. Is a D is an internal node? No. Why? Because it don't have any children. At least no one child also. Therefore, D is not a internal node. Okay. So next, C is also internal node, which are the children. So the node which has at least one child, which has the children, then that node are called as the internal nodes. So now what are the internal nodes? A, B, C, F. They have the children. Therefore, they are called internal node. Next, external node. This external node also called as a leaf, a node without children. A node without children. When you take E has any children? No. Therefore, E is an external node. I, J, K, external nodes. G, H, external nodes. It don't have children. So D don't have children. Therefore, they're external nodes. Next, ancestors of a node. Ancestors of a node means like a parent, a grandparent. For example, when you take F or E parent is B parent is A. They are called as ancestors. Ancestors. Descendants of a node. For example, our children are the descendants. So here, for example, B is there. B children is here. B child is F. Okay. Next, children is I, J, K. So F, I, J, K are the descendants of B. Okay. So ancestor means our previous one, parents, grandparents. So descendants means our children. Like so, here if you take best example, one more time I'm saying, when you take B, otherwise when you take F ancestors are ancestors B A. Okay, so now F descendants means I J K. Okay, or in another way, for example, B is there. B ancestor is A. B descendants are what? F, I, J, K, E. They're all under the descendants. Okay. Next, this depth of the node, height of the tree, we will learn in the next coming minutes. These are the basic things. This depth to height, I'll try to explain by taking the some diagram. So now compare depth and height of the depth and height of the node. So first to read definition, we'll take one example. Sorry. A, B, C, D, E. Okay. So now we do one more. Some F, G, H. So now, what is the depth and height? For example, when you take B node, uh, whatever the path length, how many edges the path length from root, so that is called as the depth. From the B node to whatever outward length is nothing but the height. Okay, here the depth of the node, one more time, the depth of the node Ni is the length of the path from root. The depth of the node is the length of the path from root. For example, B. What is the B path length? How many edges? 1. Therefore, depth is 1. So now height. The height of the node is the length of the longest path from node Ni. So what does that mean? For example, B. B2, how much length for this one? Therefore, 1 unit. Therefore, it is a height is a 1. For example, to understand more clearly, you go for A. For what is the A depth? Started from A only. Therefore, depth is 0. Depth is 0 for A. Okay. Here I am writing depth. Depth of A means 0. Next, height. What is the height means? The height is nothing but the height of the node is the length of the longest path. For example, length of the longest path to up to leaf. Here how many units? How many edges? 1, 2 up to leaf 2. Here how many? 1, 2, 3. So longest path. Which is the longest path? This one. 1, 2, 3. Therefore height of A is 3. Two paths is there. One is 2, one is 3. Which is a height? Longest height 3. Therefore that is the height of A. So the same way, not only for A, you can calculate for other vertices also that are called nodes. For example, if I want to be calculate, for example, I want to be calculate for C, depth of C. So you have to see how much length from root, how much length from root. So how much length, how many edges will be there? 1 edge. So depth is 1. Next, uh, height means from that node to leaf. How many units will be there? How many edges? 2 edges. Therefore height of C is equal to 2. Depth is 1, height is 2. So this will discuss next detailing. Here we will discuss about detailing. So now we are written this is one tree. This is one tree. For this tree we calculate each node, what is the height, what is the length. When you come to A, started with A only, depth is 0. Height, longest path, for example, up to leaf, the path means up to leaf. For example, here 1, 2, here 2 units. Up to leaf, here 2 units. 1, 2, 3, here 3 units. So the height is 3. longest path. When you come to the B vertex, when you come to the B vertex, what is the depth? Up to root how much units? 1. So therefore depth is 1. Next is height. Height means what node to leaf. Node to leaf how many units? One edge will be there. So height is 1. So next, when you come to C, what is the depth? Root up to root how many edges will be there? One edge. So depth is 1. Height. How many edges will be there up to leaf? There is no any leaf, therefore height is 0. Okay. The depth is nothing but to calculate back number of edges. Height is nothing but to calculate uh, up to leaf how many edges will be there. Up to leaf means that what that node means vertex to down how many edges will be there, that you have to calculate as a height in that longest path. In that longest path means just now we are seeing for A 1 2 3 3 edges here 1 2 3, so you have to take longest 3 units. Okay, that is for A. Next, when you come to C, so C completed. When you come to D, so what is a D? Backwards how many edges? Up to root 1. Therefore depth is 1. Height. How much height will be there up to leaf? 1. Therefore its value 1. You check it for E. For E, back up to root how many edges will be there? 1. Therefore depth is 1. For E, up to leaf how many will be there? Here 1, 2. Here how many? 1. So you have to choose the longest path. So this is the longest path. How many edges? 2 edges. So therefore height is 2. Here listen one more time. For E, backward up to root how many edges? 1 edge. Therefore depth is 1. Next, height. Height means up to leaf. For example, up to leaf here 1 edge. That means this is a 1 edge. Next, up to leaf here how many edges? 1 2. So which is the longest, you have to take that. So therefore 1 2, height is 2. Like that you can calculate the depth and height of the node. Node means here vertices. Every time we refer node here vertices. Okay. Next. Wait a minute. So now, whatever the we discussed previously, the node, the parent, siblings, that all we will discuss with example one more time. This is a root for the given graph. A is a root. Next, leaves. Leaves means we just recall the definition. The nodes which have no children. Leaves means the nodes which have no children. C, no children. Therefore, C is a leaf. Therefore, C has a no children. Therefore, C is a leaf. IJ, no children. IJ don't have children. Therefore, IJ are the leaves. K, K don't have the children. Therefore, it is a leaf. LM don't have children. Therefore, they are the leaves. G don't have children. Therefore, G is a leaf. C don't have children. Therefore, C is a leaf. Leaves means the nodes or vertices which don't have children. Next, siblings. We recall the sibling definition. Who have the common parent, they are called as siblings. So now, the B, C, D, common parent is A. Therefore, B, C, D are the siblings. F, G, H are siblings. Why? Because their parent is D. I, J, their parent is E. Therefore, they are siblings. LM, their parent is H. Therefore, LM are the siblings. If they are the common parent, then they are called as the siblings. Next, what is the internal nodes we learned? Internal nodes means uh, what we learn internal vertices, are you called internal nodes also. They have at least one child. I'm recalling internal vertices or internal nodes, at least one child. A has a child, therefore A is an internal node. B has a child, B is an internal node. C has a child, no, therefore C is not internal node or internal vertices. D has a children, therefore D is an internal node. F has a child, therefore F is an internal node. G no have children, therefore not internal node. Uh, H have the children, therefore H is a internal node. So internal nodes or vertices means at least one child. If that node has at least one child. Next, wait a minute. Next, ancestors. So what we call ancestors? For example, you have to check previous vertices, simply previous vertices, ancestors of K. So K ancestors means like a parent, grandparents, all that. So F is ancestor, F2D is ancestor, A is ancestor. So ancestors of K or what are that? F, D, A, like a parent, grandparent, like that. Next, descendants of D. Descendant means like a children. For example, different descendant of D. Children, their children, they are called as the descendants. So when you take D, D descendants are F, G, H, K, L, M. Descendants of D means children and their children. So that are all come under children, their children, all that are come in the descendants of D. So here for D descendants are F, G, H, K, L, M. Okay. Next, subtree. In a tree, if you construct another tree, so in a tree, if there is another tree that are called as a subtree. For example, subtree at B, start, you take from B to this part of the tree, you take this part of the tree, this is a subtree. You take this up, start with B, this is a part of the tree, therefore this is a one subtree. In a tree, the part of the tree is nothing but the subtree. Next, root level. What is root level means? This is called as a level 0. This is called level 1. Okay, this is called, these are all called level 2. Okay, this is called level 3. So these are called as initially level 0. This is level 1, level 2, level 3. Next, for this problem, we find the answers. We try to find the answer. Which vertex is a root? First question. What is a which vertex is a root means? A is a root. Okay, answer A is a root. Which vertices are the internal vertices? So just now we said internal vertices means have at least one child. So A has a children. So second answer, B answer. Wait a minute, I'll change the color. So first answer for A, first answer, which vertex is a root means A. Next, the second answer, which vertices are the internal? Internal vertices means at least one child. So A has a children, therefore A is the internal vertices. B has a children. B is the internal vertices. Next is C don't have children. So next D. D have the internal children. Therefore D is the internal vertices. E have the children. G have the children. So E, G, E, G. Next H have the children. H. I have the children. Next O have the children. Which have the at least one child. They are called as internal vertices. Which vertices have leaves? The vertices which don't have children, they are called as a leaves. So no children. C. No children. J, K, L, M, N, Q, R, S, P. No children. This is the answer for C. Okay. Next, which vertices are the children of G? So D answer. Which vertices of children of G? So children of G, what are that? L, M. Okay. Next, E answer. Which vertex is the parent of O? O parent is who is that? I. E answer. Next, which vertices are siblings of E? Siblings of E. We just draw one line. These are what are the siblings? For F answer, F comma G. E siblings are F, G. Okay. E siblings are F, G. Next, which vertices are ancestors of M? Ancestor. The question is G. Which vertices are ancestors of M? For M ancestors, when you come to M ancestors, G, B, A. So this answer is G, B, G, B, A for this. Which vertices are the descendants of D? Descendants of D means their children, grandchildren, like that. So what are that? Wait a minute. For H, descendant of D. Descendant of G means H, N, I, O, P, Q, R, S. These are all comes under descendants of G. So these are detailed. We discussed one question which is give all the which covers all the definitions. Next, we see one more problem. Find the depth and height of the each node. For example, we write here node. Next, depth. Next, height. So come to A. A starting itself only, no depth. Height. Height means you have to check the longest path up to leave. So 1, 2, 3, 4. If you take this one, 1, 2, 3 only. Longest path means 1, 2, 3, 4. So it is 4. Next, for B, what is the depth? Up to root. How many edges? 1. So depth is 1. Next, height, longest path. 1, 2, 3. Next, next to come to C. When you come to C, what is a C? Depth 1. What is the height? 1, 2. Height is 2. Next, A, B, C. Next, D. For D, what is the depth? 1, 2. Okay. What is the height? D to leave. How many edges? 1 edge. Therefore, height is 1. Next, for E. When you come to E, what is depth. So for E, depth means up to root 1, 2. So depth is 2. Height, for the height 1, 2. Height is 2 up to leave. That is nothing but depth means up to root how many edges. Height means from that node to up to leaf how much edge, how many edges is there. Okay. Next, E completed. I'll do one more. E after F. So what is the F? What is the depth? Up to root 1, 2. Depth is 2. Height up to leaf. Up to leaf, what is the height? Only 1. Therefore 1. Like this, you can calculate it for remaining also. Like this, you can calculate for remaining also.